Hello dear learners, today in this video we are going to discuss a very important topic, congruence of integers modulo a fixed integer. So what does it mean? Let's see. Congruence of integers modulo a fixed integer, no? So suppose 7 is a fixed integer. It is fixed integer. And we consider two more integers. We have to consider two more integers. So 16 and 2. 7 is the fixed integer and 16 and 2 are two more integers. Then 16 will be called modulo 2, congruent to 2. 16 will be set to congruent to 2 if 16 minus 2 is divisible by 7. And we know that 16 minus 2 is equal to 14, which is divisible by 7. No? We know that 16 minus 2 is more 14, which is divisible by 7. And this thing is written in a mathematical representation. 16 is said to be congruent to 2. 16 congruence to modulo what? 7. So this thing 16 minus 2 is equal to 14 is divisible by 7. This statement is mathematically represented as 16 congruence to modulo 7. Here it is nothing but the remainder, and this is the dividend, and this is the divisor. That is, the game of this thing is about the remainder, dividend and divisor. These three things, no? So one more example I am taking. Suppose 5 is a fixed integer and 10 and 3 are two more integers. Then 10 minus 13 and 3. Suppose 13 and 3 are two more integers. Then 13 minus 3 is equal to 10, which is divisible by 5, no? And this thing is written as 13 is congruent to 3 modulo 7, modulo 5, no? That means when a fixed number divide the difference of two number, then this thing is represented in a special arrangement in mathematics or advanced mathematics, which is called congruence of integers modulo a fixed integer. If we define it in definition, let n be a fixed integer. A and B are two more integers. If n be a fixed integer and a, b are two more integers, then a is said to be congruent to b if a minus b is divided by 7, divisible by 7. If n divides a minus b, that means n is a fixed integer and a, b are two more integers, then a will be said to be congruent to b, if n minus b is divisible by n. Suppose as we take an example 13 and 3. 13 is said to be congruent to 3 with modulo 5. 13 is said to be congruent to 3 with modulo 5 if 13 minus 3 is divisible by 5. So 13 minus 3 means 10, and 13 minus 3 means 10, and 5 divides 10. So this is the special arrangement of these things. So therefore we can write A is congruent to B modulo mod n or modulo n. This is n, no? This is the definition. That means if a and b are two integers and n is a fixed integer, then a is said to be congruent to b with modulo n, when n divides a minus b. I am taking two more examples. Suppose 32 and 4 are two integers and 7 is a fixed integer. Then 32 minus 4 is equal to 28 and 7 divides 28, we know. So these things can be written as 32 is congruent to 4. Here we write the remainder here. This number is nothing but the remainder with mod 7. Mod 7 means divisible by 7. That means from this line, if we want to write the reverse line, from this line we can write 7 divides 32 minus 4. So 7 divides 4. This line can be written as in this way and this line can be written as in this way. So this is the concept of modulo. So now we will discuss about the properties of modulo. So first property, theorem 14, let n is greater than 1 be a fixed integer and a, b, c, d are 4 integers, then a is congruent to a modulo n. That means suppose 3 is congruent to 3 modulo any integer. Modulo you can give any number here. 3 congruent 3 modulo any number. If you write here 110 whatever number, no? Suppose I am writing 7, then 3 minus 3 is what? 3 minus 3 is 0 and 0 is divisible by 7 and this is divisible by 0 is divisible by every number. So we can write that a is congruent to a modulo n. That means any number. 4 is congruent to 4 with modulo any number, no? So this property we have to prove. Solution, how will you prove that? For any integer a and a fixed positive integer n, we have a minus a is equal to 0, no? A minus a is equal to 0, which is divisible by any number. Since 0 is divisible by any number, then 0 will also be divisible by n, no? 0 is divisible by n, and we know that if a minus b is divisible by n, then we can say that a is congruent to b with modulo 7. Now here a minus a is divisible by n, so we can write a itself is congruent with modulo n. A itself is congruent to a with mod 7. In short form we can write mod n, always 7 comes. So a, that means every integer is itself is congruent with any fixed integer, no? Suppose 5 is congruent to 5 with any mod of any number. 6 is congruent to 6 with mod of any number. 7 is congruent to 7 mod of any number. Here you can give any number, no? Since 5 congruent to 5 means what? 5 minus 5 means 0. 6 minus 6 is 0. 7 minus 7 is 0. So these things are divisible by any number here, so that any number is taken as n, no? So here a is any fixed integer, a is any integer, and n is the fixed number. So a minus a is equal to 0, which is divisible by n. Therefore a is congruent to a with modulo n. That means we can say that every integer is itself is congruent with any fixed number, no? So second property we'll see. So second property is that a congruent b mod n implies that b congruent a mod n. if A is congruent to B with mod say n, then B is also congruent to A with mod n. Suppose if 8 is congruent to 3 with mod 5, then 3 is also congruent to 8 with mod 5. No, that means their reverse thing is also correct. No, so if A is congruent to B with mod n, then B is also congruent to A with mod n. No, so let A is congruent to B mod n. A is congruent to B mod n means what? From this line we can write n divides A minus B. No? N divides A minus B. Now see, A minus B is nothing but a number. Suppose 2 divides 6. If 2 divides 6, then 2 divides minus 6 also. If we give here minus, it doesn't matter, it doesn't affect. So if 5 divides 15, then 5 also divides minus 15. No? So from this concept we can write, if n divides A minus B, then we can write n divides minus A minus B. If we give as it is, if you consider this thing as a single number, as like 6, suppose this number is 6, so if we give a negative number in front of it, then 2 also divide the negative that number. So A minus B is a number, n divides A minus B, then n will divide negative of A minus B, because 2 divides 6, then 2 divides minus 6 also. So n divides A minus B, then n divides negative A minus B. So negative A minus B again can be written as what? Minus means plus, B minus A. So from this line what can we write? A congruent to B mod n. If we write n divides A minus B, now n divides B minus A means what? B is congruent to A mod n. So very easy, very important and very easy. No? Let's see next property. Next property, A is congruent to B mod n and B is congruent to C mod n, then A is congruent to C mod n, A is congruent to B mod n. How will we solve it? A congruent to B mod n. From this line we can write n divide A minus B. No? Again B is congruent to C mod n. From this line we can write B divide n divide B minus C. No? Now see, n divide A minus B, n divide B minus C. As earlier we have proved that if A divide B and A divide C, then A divide B plus C. No? A divide B plus C. So from these two lines we can write, what can I write? We can write n divide A minus B and n divide B minus C. Therefore we can write n divide A minus B plus B minus C. Since if A divide B and same A divide C, then we can write A divide B plus C. So if n divide B minus C, n divide A minus B and n divide B minus C, then we can write n divides A minus B plus B minus C. So here we can write n divide B cancel A minus C, and this thing can be written as n divides A minus C can be written as A is congruent to C mod n. No? So easily we can prove the property. So one property always come in exam, very important properties these are. Let's see next one. Next property, A is congruent to B mod n and B is congruent to C mod n, then we have to prove that it implies that a number A plus C is also congruent to B plus D and A into C is also congruent to B into D. No? That means if there are two congruent, then we can, if we add them, then they are also congruent. That means A plus B is congruent to B plus D, B plus D. sorry, it is quite wrong here. We have to write A is congruent to B mod n and C is congruent to D mod n. It implies that A plus C, this A plus C is congruent to B plus D with the same mode, no? So how will we prove? A is congruent to B mod n. From this line we can write A minus n divides A minus B. N divides A minus B. Again, C is congruent to D mod n. D mod n. So from this line we can write n divide C minus D, no? Therefore n divides A minus B, n divides C minus B. You can write n divide A minus B plus C minus D, and this, if we write by arranging, we can write A plus C and C are written together, and minus B plus D, no? Since minus sign is present in front of both B and D, so minus is taken common and B and D are written together with plus. So if we consider this one a single number and this one a single number, suppose n divide A minus B can be written as what? A is congruent to B mod n. N divides A minus B means A is congruent to B. N divides A plus C minus B plus D means what? A plus C is congruent to B plus D. So if we take this side, it will be in minus, subtracted, no? It will be congruent to mod n, no? So very easily we can prove it. Next one, A is congruent to B mod n. This can be written as n divide A minus B. So if n divide A minus B, then we can write A minus B is equal to n into something. When 2 divides 6, no? Then we can write 6 is equal to 2 into 3. That means 2 into something. So n divides A minus B, that means A minus B into something. Suppose this is taken as K1, n into K1. So we can write A is equal to B plus n into K1. N into K1. Again, C is congruent to D with modulo n. Then we can write n divides C minus D. So n divides C minus B means what? N divides C minus D means what? C minus D is equal to n into something, and this is taken as n into K. So C can be written as D plus n into K2. Now we need to prove that AC is congruent to B minus D congruent mod n. So first of all we will find AC and then we will find BD, no? AC. Therefore AC means what? A means B plus n into K1 plus D. C means what? Into, since we are multiplying here, into D plus n into K2, no? So if we multiply B into D plus B into NK2 plus this thing into D, that means D into NK1 plus N square K1 K2, no? Now see, here we have AC, no? So BD, from this whole thing we can write n common, no? We can take n common. If we take n common, here BK2 plus here DK2 K1 and here n K1 K2, no? Now see, if we take BD this side, AC minus BD, here we have n into BK2 plus DK1 plus NK1 K2. That means AC minus BD is equal to n into something. If we have A minus B is equal to n into something, that means we can say n divides A minus B, n divides A minus B, no? a minus b is equal to n into something. That means n divides a minus b. So from here we can write n divides ac minus bd. N divides ac minus bd. So n divides ac minus bd can be again written as what? AC is congruent to bd with mod n. So this is the proof. Next one we have a is congruent to b mod n, then a plus c and b plus c are also congruent with the same mode. A is congruent to b, then a plus c and b plus c are congruent mode n. That means if same number is added both sides, then those are also congruent, and if same number is multiplied both sides, then they are also congruent. So we have to prove it. A divide a congruent b mod n. This can be written as n divide a minus b. N divides a minus b. So n divides a minus b can be written as, if we write in this way, a plus c minus b plus c. Will it affect a plus c minus b minus c? Here if we break it minus b minus c, then plus c and minus c will get cancelled. Again we will get the same thing, a minus b. So from this line what can we write? A plus c is congruent to b plus c with mod n. That means we can write, if two numbers are congruent with a fixed number, then if we add same number both sides, then those numbers are also congruent to each other. So it is a number. For b number we can write a is congruent to b mod n. So if we write, it means a divides a minus b. Yes or not? Suppose if 2 divides 12 minus 4. If 2 divides 12 minus 4, then we can multiply any number with them. Any number with them. Or suppose 2 divides 6. Then if we multiply any number with 6, any number, if we multiply any number with 6, then also it will divide. If we multiply 3 with 6, then also divide. 2 will divide. If we multiply 4 with 6, then also it will divide. So n divides a minus b. That means if we multiply any number with this number, then also n will divide the number. As because 2 divides 6, then 2 will divide 3 into 6, 4 into 6, 5 into 6, 6 into 6, any number. You can give negative number also. So n divides a minus b. So if we multiply here c, then it is also divisible by n, because when a fixed number divide another number, then if we multiply any number, it doesn't matter. So it can be written as n divide ac minus ab. So it can be written as ac is congruent to ac minus bc. AC is congruent to bc with mod n. Next one. So a is congruent to b mod n implies that a to the power k is congruent to b to the power k mod n. So a is congruent to b mod n. A is congruent to b mod n. Again we can write a is congruent to b mod n. A is congruent to b mod n. Suppose a is congruent to b mod n. Again we can write a is congruent to b mod n. Again we can write a is congruent to b mod n. So in this way, if we write k times, k up to k times, k times, then k times we can, if we multiply both sides, then here k number of a are there, so we can write a to the power k is congruent to here k number of b are there, so b to the power k mod n. Is because when they are congruent to each other if we product. Suppose A is congruent to B mod n and C is congruent to D mod n, then we can multiply them. AC is congruent to BD, then here also A is congruent to B mod n, A is congruent to B mod n, then A square will be congruent to B square mod n. If we write 3 number 3a, A cube is congruent to B cube mod n, then if we write up to n times, that means A into A into A into A into up to k times, if we multiply both sides, k times A, and is congruent to B into B into B into B up to k times and mod n, then here A k times are there, that means A to the power k is congruent to B k times are there, B to the power k mod n. So these are the properties, and this property will be used most frequently in our exercise. So remember this, these are the properties of mod. So, and properties are very important. In always one properties comes in exam. So thank you.